Hello everybody, this is Michael. In this video, we will talk about the coding and simulation for Stator Machine Solution 02. Okay, so from previous video, we already get all the stators here, and the stators transition table here. So we can coding according to this table and all the stators. Okay, so the first things we open our Visual Studio Code. We new one file. Okay, and we save it. We save it. We save it into this folder. We save it into this folder, and the name is sequence detector .v. Okay, save. Okay, so the first things we added some common information. Okay, and the next we define the module name and the module interface, module name, module interface, input clock, input reset, input sequence in, data in, output register detector output. Okay, so next, because we are using the stator machine, of course, we needed to define the current state and the next state. The current state and the next state is 6B. Okay. So next, we will define the state name. Okay. This is the state name. S0, 1, 2, 3, 4, 5. Okay. 0, 1, 2, 3, 4, 5. Okay. Okay. So next, we will use 3 always block to describe the state machine. So the first always block is like this. It's always like this. Okay. It's always like this. So it just switch the next state into the current state. Okay. When the system reset the current state, it will be the S0 state. It will be the idle state, S0. Okay. So next, the second always block, we will define it like this. Okay, it will be like this. So this is the second always block. It describes the stator switch. The stator switch. We will check here. Okay, the moment. So you will see here. So this is the current stator. This is the current stator. The current stator. When the input is 0 for the current state S0, it will still keep into the S0. The next state will be S0. If the input is 1, the next state will be S1. Okay, the next state will be S1. For the S1 current state, if the input is 0, the next state will be S0. Okay? So here, S2. This is S3. S2. Okay? 0, 4. 0, 4. 0, 5. 0, 5. 0, 0, 1, 1. Okay, so these status which need to exactly match this table. Okay, this for the second always block. Okay, so next, the last always block is to output the detector result. Okay, so we do it like this. We do it like this. Okay, so this is the third always block. Okay, when the current stator is S0, 1, 2, 3, 4, the detector output detector is always 0. Okay, here 0, 0, 0, 0, 0. When this stator is S5, the output will be 1. The output will be 1. Okay, default is used at 0. Default, the output will be 0. Okay, the output will be 0. Okay, so this is three step always block to describe the state machine. Okay, in the end, we need to edit end module. Okay, we need to edit end module here. Okay, we save it. Okay, save it. So this is the code. This is the code. So let's review it again. Here is module name, module interface. Here is current state and the next state defined. Here is the status defined, status name. And here is the first always block. Okay, switch the current state to the next state. This one is the second always block. We use case language to describe the status switch according to the status transition table. This is the last always block. We output the different value according to current status. Okay. So this is the stator machine solution for sequence detector. And the next step we will use. Okay. So the code is here. We will use the same test bench from the register solution. We use the same test bench file. We copy it and put it under this folder. And we create one folder, new one folder. Model C. We use this folder to keep the Model Sim project. Okay, so next I will open my Model Sim software. Okay, so this is my Model Sim software. Create a project. Project name is Sequence Detector. We will save it under this folder. Put it into this folder and click OK. Just a moment. Okay, so we added files. we added the two file. Open and click OK. Click close. So next step, we compile it. Compile all. Okay. So it's successful. So next step, click the simulate. Start simulation. Okay, click here. Click OK. It's loading. Okay, so this is a simulation interface. We added our objects into the wave. Click any places here, added to wave, signal in region. And the next step, we change it. The test time is like this. We move it a little bit to see the waveform. Okay. Okay. So next we click here, run. Okay. Click any places. It will stop here. It will stop here. Go back to the waveform. And we click any places. And then we zoom. You will see here. So this is the simulation result. So you will see the result is here. This is 11011, and then we output the detector signal is here. 11011. Output the detector signal is here. So you will see we have 2 clock delay for the output result detector. For this signal, we have 2 clock delay. Okay, so next time we will discuss a little bit about how to optimize the status machine solution. Okay, do some optimize for this solution to make the output is synchronized with the data change. Okay, so that's it. So this is for this video, and see you next time.